Hello and welcome to Steelhead's presentation on Roadway and site closeout. In our group, we have Alex, Aviv, Brandon, Coleman, Manja, and Marcus. Roadway. For the roadway, after the culvert installation pieces are complete, we have successfully transformed the project site into a culvert, which was the goal all along. Once that is done, we have to make it functioning back into a road. Therefore, we start by laying down some CSBC, followed by the HMA process, which will be talked about later, and finally a multitude of roadway components such as roadway pavement markings, guardrails, and much more. The top safety risks involved with this are the workers and equipment fall off from the side of the road, just in case, because of the height of the culvert from the side of the road, it is a risk that machinery or people take when they're working on the construction site. The other component, which is throughout the project, is the human and machine interaction component, where as long as we always have work going on with heavy machinery, like we do in this case, it's always a risk of injury and accidents. Here's a risk more specific to the project is the low visibility. In case we schedule this at night or certain components of it at least, the safety risk increases with the lower visibility and it can cause injury or accidents. The top quality risks for the roadway are with the culvert underneath, the compaction quality may be impacted. Depending on the schedule, the visibility also may be a quality risk as if we can't really see as much, the work isn't going to be as efficiently and nicely done. The other component is weather conditions, which we cannot control, but these conditions can impact the quality, especially with HMA, because HMA is best done in warm weather, but rain and cold weather can always impact how well HMA is laid down and cures. And here's a look at a supposed schedule of the roadway. Of course, it could be adjusted, and as we will do later.
Activity 1, CSBC. The CSBC activity involves the placement and compaction of a layer of crushed aggregate material. This activity begins with delivery of CSBC material using dump trucks and even distribution of the CSBC across the area using wheel loader and dozer, followed by grading using grader and dozer to ensure proper thickness and slope drainage. Once shaped, the material is compacted using rollers to achieve a specified density, ensure a stable foundation for the subsequent layers such as HMA. We'll be using crew B36B, and we have a productivity of 104.375 cubic yard per hour. For the labors, I'll be using 2 general labor, 1 motor grader operator, 1 loader operator, 1 dozer operator, 1 roller operator, and 1 dump truck driver. And note, $25 of medical expenses per hour is not included. For equipment, we'll be using 1 grader, 1 loader, 1 dozer, 1 roller compactor, 1 truck tractor with 1 water tank trailer. For the materials, we'll be using 3/4-inch crushed aggregates with a quantity of 165 tons. Predecessors. The backfill of the culvert must be finished before CSBC. And for interactions, after CSBC of the roadway section is finished, HMA can start, and this is before CSBC of the shoulders is finished. Inspection, testing, and hold points. Subgrade must be uniform and stable. Confirm that CSBC material meets gradation and quality specs, and ensure uniform thickness and proper moisture conditioning. Perform density testing. Check that compacted surface is within the design grade. Confirm the compacted surface is smooth and free of loose material. Limitation and rules. Rollers can operate in levatory mode on top of the culvert. CSBC placement and compaction must not occur in frozen, saturated, or muddy subgrade. Each lift must not exceed 6 inches. Moisture must be within 2% of optimal. Minimum of 95% of maximum density. Final surface must be within 0.04 feet of design grade. CSBC must be protected from contamination. Equipment and traffic is not permitted on CSBC until compaction is finished and approved. This is the thickness and plan view. The red section is the shoulder of CSBC. It has a compacted depth of 0.35 feet. The green section is the main roadway section of the over-excavation. It also has a thickness of 0.35 feet compacted. The blue section is the roadway section that's on top of the culvert. It has a total depth of 1.15 feet, and it will be done in 3 lifts since the thickness limit is 6 inches. Working sequence. First, do the CSBC on top of the culvert with the first lift of 0.5 feet. And second, do the south side of the culvert. Next, do the second lift of the CSBC that's on top of the culvert with the compacted depth of 0.5 feet, followed by the north side of the culvert. Next, going back to the section that's on top of the culvert and do the last lift with a compacted depth of 0.15 feet. And lastly, do the shoulders. Activity 2, HMA. HMA activity involves the placement and compaction of a heated asphalt mixture composed of aggregates and bitumen. The process begins with transporting the HMA from the plant to the site. HMA in this project requires paving done in 3 subsequent lifts. HMA is carefully spread using an asphalt paver to achieve the desired lift thickness and alignment. After placement, the asphalt is compacted using the tandem roller and pneumatic rollers to remove air voids and ensure a smooth stem surface. After compaction, the layer is set to dry before the next lift can be started. We will be using B25B crew for this activity, with a productivity rate of 100 tons per hour. For the laborers, we'll be using 7 general laborers, 1 paver operator, and 3 roller operator. Note that the $25 per hour medical expenses is not included. For the equipment, we'll be using 1 asphalt paver, 2 tandem roller, and 1 pneumatic roller. For the materials, we'll be using 156 tons of HMA class a half inch. The roadway section of CSPC must be finished before HMA can start, and the CSPC of the shoulder will not affect the HMA. Inspection, testing, and hold points. Verify the CSPC layer is properly compacted and clean. Check mix temperature. Conduct density testing. Take core samples. Perform straight edge test to confirm smoothness. Visually inspect for flushing, segregation, or surface defects before open to traffic. Limitation and rules. Rollers can operate in vibratory mode on top of the culvert. HMA placement is not allowed when surface is wet, frozen, or during rain or snow. Minimum surface temperature of 45 degrees required. Each lift of HMA must comply with thickness limits. Compaction must be completed within the workable temperature. Traffic cannot be opened on freshly paved HMA. HMA delivery trucks must be tarped, and release agents must not contaminate the mix. This is the plan view. The green section is the main roadway section of HMA that's for the over-excavation, and the blue section is on top of the culvert. This is the HMA lift thickness. This is a more detailed look. This will be done in 3 lifts, 1, 2, and 3. The first lift have a lift thickness of 0.35 feet compacted with a 25% compaction rate. It's 0.467 feet pre-compacted. Lift 2 will have a 0.3 feet compacted depth, and lift 3 will have a 0.15 feet compacted depth. Paving sequence. The widest part of the road is 32 feet, and the paver have a width limit of 17 feet, so this will be done in 2 phases. First, pave the first lift of the northbound, then followed by the first lift of the southbound, followed by a second lift of the northbound, and then the second lift of the southbound. In the diagram, the light blue represents the first lift, and the darker blue represents the second lift. After that, pave the last lift of the northbound, followed by the last lift of the southbound. In the diagram, blue represents the second lift, and dark blue is the third lift. And this completes the HMA.
Okay, now we have activity 3, joint sealing, which involves the process of joining the new and existing pavement that are 27.6 feet in width. And before applying the joint sealant, the cracks and joints needs to be rooted out and cleaned using a hot air lens to clear any debris within the cracks. And after cracks are prepared and clear, crack sealant will be applied to the cracks by using a heated liquid asphalt, often some form of rubberized asphalt that is melted using a tar kettle. The crack sealant will then be applied using a hose and one. And after that, a glance oil will be sprayed onto the cracks to prevent any sealant sticking on the vehicle's tire. Additionally, crack sealing is best done in moderate temperatures and is most effective if performed immediately after cracks develop. And the crew required will be B37F. And here are the laborers, equipments, and materials needed for joint sealing. The productivity will be 250 linear feet per hour. Predecessors will be CSBC and HMA. And right after this activity is completed, pavement marking can start while joint sealing is curing because of the glance oil that is applied to the cracks. And here are the limitations and rules set by WashDOT. And yeah, that's it for activity 3.
Activity 4, the guardrails. The installation of the guardrails activity involves placing the steel W beam section at the roadway shoulders to enhance safety and prevent vehicles from falling into hazardous areas. Additionally, the process includes setting up the post spacing, transporting guardrail posts, aligning and bolting guardrail sections, and finally installing the end terminals. Crew B6 will be used. So here is the labor and equipment information. The only thing that I think is necessary to point out is that we will use 6 main steel W beam guardrail sections, and for each section we'll have 10 11-inch diameter bolts, and two W6 by 12 steel posts, and we'll also have to use a pickup flatbed truck to transport equipment and the end terminal sections, which will be four in quantity. So here's the main work description, the predecessors. This is one of the final tasks of the roadway, the interactions, inspections, testing, and hold points to test the structural stability and the proper alignments of bolts, and also the limitations and rules. Here are the locations of and the stations of the guardrails, and where it's where it's supposed to start and end. Here's a side view of the guardrail section and where the steel posts are meant to be bolted. And finally, here are the posts and end sections of the guardrail. And orange will be the ones that we'll be using in terms of the W-beam and steel posts. And at the bottom right, we'll have the end section plan and elevation view of the end terminal sections.
Activity 5, which is pavement markings. And this involves applying acrylic waterborne paint to road surfaces and includes the installation of two white edge lines and one yellow center line that will both be 4 inches wide and 81.67 feet for each set of lines as elaborated by the diagrams provided. And the crew required will be crew B78. And here are the laborers, equipments, and material costs for this activity. The productivity will be 2,500 linear feet per hour. And the predecessors will be CSBC, HMA, and joint sealing, which must be completed for starting this activity. RPMs will also start once the center line is painted, as well as the installation process of guardrails. Here are the limitations, rules, and definitions as per WashDOT for this activity. And right after that, we have activity 6, which is RPMs or raised pavement markings. And this includes applying two 4x4 inches type 2 RPMs at a spacing of 80 feet between each other. And the placement of these RPMs will be at the start and end of the new pavement. It will also involve two common laborers to install these RPMs. And these two common laborers will be taken from the pavement marking crew B78. Here is the installation process of RPMs. And here are the laborers and material costs for this activity. There will be no equipment for this activity, and the productivity will be 15 RPMs per hour. Predecessors will be CSBC, HMA, joint sealing, and pavement markings. Guardrail installation process will start right after this activity, and as stated before, the laborers from crew B78 will be utilized. And here are the limitation and rules set by WashDOT. And it is also stated that reflectorized RPMs are not required for center line, but in this case, since the highway is not continuously illuminated, we will be utilizing the reflectorized RPMs. And that is it for activity 6.
Now on to site closeout. For site closeout, the purpose of this activity is to put the final touches and complete any and all work items either left unfinished by other construction components or that were put in place earlier by the construction crew for this project. Firstly, we start with the chain link fencing and the head wall construction, which will take place as the final erecting construction components. From here on, it will be deconstruction components such as the removal of TESC and traffic control, along with the cleanup and the restore, which includes sweeping and the restoring of the storage sites. For this, safety risks aren't much, but we still have some, which is active. Since this is still an active construction site, we should follow all the construction safety requirements, especially for the head wall and the chain link fencing, as there's the risk of falling and the heavy material. It's important that all equipment and materials are properly disposed of and the site is clear of any hazard to the public. Since we are going to be reopening the site after this phase, it is important that no construction materials or equipment is on the road or in vicinity of being a hazard. The road may be open to traffic for some of this work, therefore anticipating traffic and proper machine operation is needed for the rest of the components. Because if the road is ongoing and there's still work going on, we got to make sure we follow all safety requirements. Top quality risks. There isn't much, but we can try to get to some, which is weather conditions may impact the cleanup or the TESE removal, as if there's not proper BMPs, the weather can impact those BMPs. The ongoing traffic will be a quality risk. If certain tasks are not completed in time, they will be difficult to do after the fact. And ultimately, site closeout is a checkpoint or a milestone for the whole project. So if everything is functioning, this is a good place to find out if there are any mistakes along the way. So that's probably the best quality management component. As you can see, this is somewhat how a schedule can be outlined.
This is activity 1 of the site closeout, which is to install a chain link fence into the culvert head wall and wing walls. For this, we'll need 2 laborers. And that will be fence erectors under the King County database at a rate of $54.65 an hour, plus the additional $25, so $79.65 an hour. And then we'll have a flatbed truck, which is just a standard pickup truck, just to haul materials to the job site. That'll be $422.09 a day. And then materials, which I found on under RS means is what most closely matched what the plans said, is going to be $53.76 per lineal foot at 80 lineal feet, giving us a total of $4,300.80. And there's nothing really that we'd want to go alongside it, so there's no interactions, no, and neither other inspections, testing, and hold points or limitations and rules. So that would be it.
Activity 2 is the Compost Amended Vegetative Filter Strip, or CAVFS, and this includes the installation of 80 feet of sloping vegetative filter strip landscaping adjacent to the culvert to improve infiltration and act as a sheet flow. And this also includes installing flexible guideposts and BMP markings. The required crews for this is 4 laborers. So I wasn't able to find RS means for this, but we calculated a productivity of 3.7 cubic yards per hour. This is because the total volume of filter strip is 18.74 cubic yards. And we estimated through research that it would take about 5 hours with 4 laborers. And that's how and we got the 3.7. So we would need 4 laborers. Equipment would include rototiller, plate compactor, pickup truck, 3/4 ton, and water tank, which is of 1,000 gallons. Materials would include 18.74 cubic yards of compost, 506 square feet of grass seed mix, and 2 of each of guideposts and BMP signs. For the work description, we would first use the rototiller to break up that native soil to about 1 foot depth, which loosens compacted ground and prepares the root zone and shapes the slope from the 2-to-1 native soil to 3-to-1 or flatter if needed slope. So yeah, late regrading on there. Then we'd unload compost and spread it over the tilled area with the pickup truck and using rakes and shovels to spread evenly through that area. Then we would till it a second time, till that compost into the loosened native soil, ensuring that compost is blended into that 1 foot depth. And then we'd grade and smooth the surface with hand tools and compact it to 85% maximum density using a plate compactor. Also applying grass seed mix and lightly water the seed area. And lastly, installing BMP signage and flexible guideposts, one on each end of the filter strip. And predecessors include culvert installation and shoulder paving. We have to confirm that the grade is about a max of 3 height to 1 vertical or flatter and that the depth is 1 foot. Make sure that we adhere to those dimensions and compact to 85% max density. And this is the details and a picture of what the vegetated strip would look like. We start from the culvert outwards, working west to east so that equipment doesn't disturb the completed work. And since the slope is fairly mild, all work is accessible by hand tools and light equipment like the rototiller and compactor. So no need for a mini excavator. Right, activity 3 is the TESC removal. This includes the removal of all temporary erosion and sediment control features, including the high visibility fencing, compost sock, and track out mats. The required crews include 8 laborers and 4 truck drivers. So we originally used the crew A2, which is 2 laborers and 1 truck driver. And I got a productivity of 325 linear feet per hour. And this is based off the RS means B62 for a fence install and removal. And to complete 900 linear feet in under 3 hours, this is how much fencing and sock needs to be removed. Our crew is scaled up from 2 laborers, 1 truck to 8 laborers, 4 trucks, maintaining that same linear feet per hour productivity of 81.25. This achieves 325 linear feet per hour total, allowing that task to be completed in 2.77 hours precisely. And yeah, so for the work description, like I said, yeah, removing around 900 linear feet of that fencing and compost sock with hand tools, disassemble and clean up both trackout mats on each side of the culvert, roll, bundle, and load the materials by hand, and use pickup truck to haul and disposal and staging. The predecessors, we need to make sure that chain link fence is done before. We have to ensure PMPs are placed before removal and that the inspector confirms vegetation and stabilization is sufficient. And we also have to protect CAVFS during construction activities. This is the plan for what to remove. We don't need to remove that erosion control blanket because it's biodegradable.
For activity 4, we have construction site cleanup. This is putting the finishing touches on the construction site, including sweeping, removing any extra materials, tools, equipment, and waste that was missed. Labor workers are 2. The equipment is just the road sweeper that's already on site for HMA purposes, and the productivity is about 15 minutes. In reality, it's much less than that, but we have to keep a minimum of like 15 minutes just for the setup and stuff. Here is the productivity and the labor and the equipment. The predecessors are TSC removal, and the interactions are this is the final sweep before opening up the road to traffic. So ultimately, everything should be done except for maybe removing the traffic control, because once the traffic control is removed, then ultimately the road is open to all other traffic. And this is almost like a checkpoint for workers to verify nothing was missed. So, yep.
Activity 5 is the traffic control removal, and this includes the removal of all temporary traffic control measures from the site, which includes 6 barricades with road close signs and 20 tripod-mounted detour cones. The required crews include 3 laborers and 1 truck driver. We use a crew B80A, which consists of 3 laborers and that truck, which matches our needs exactly, where 2 laborers are positioned as flaggers on each end of the work zone, and the 3rd laborer is responsible for collecting and loading devices onto the truck. To calculate the productivity, we use the length of the lane closure, where the zone spans about 600 feet, and we estimated that the full takedown can be completed in 1 hour. So then we got that productivity of 0.115 lane miles per hour after converting to miles. And the wages do not include the burden cost. So for work description, yeah, as I said before, we need to remove all these signs, all these cones, and put them onto a truck, return to the storage, all the while 2 flaggers on each side to control the traffic. Predecessors, this will be the TSC removal, and minimal site cleanup can be done during this. And we have to confirm that the work zone is safe to reopen to traffic before devices are removed. And all the while, we have to follow WashDOT and MUTCD standards for flagging and traffic control removal.
For activity 6, we have restore storage sites. Upon absolute completion of any critical road work, which is most likely the HMA is the last step, the laydown sites will be stripped of gravel that was laid down at the beginning of the project by the paint group. Surrounding areas will be landscaped to original conditions, which is flat vegetation or better by hydroseeding. The sites consist of 30,000 square foot each, and this area will need to be scoped, and areas will need to be determined where the hydroseeding is needed. So we're not hydroseeding the whole thing. The construction entrances are 12-inch gravel depths placed at the entrance of both locations. The storage site number 1 is approximately 1,200 square feet, and storage site number 2 is approximately 1,300 square feet, which is according to Print Group. And they placed a total of around 2,700 square feet of gravel there. Here's the number of labor workers, equipment, and materials needed. As you can see, so the hydroseeding is such a up and down measurement, so I haven't given exact measurements for that, but it shouldn't be something that we have to worry about too much. The predecessors or HMA should be complete because other activities can be taking place at the same time since this is away from the construction site. For this, it doesn't even have to fit the weekend time frame as it's located off the road and away from the traffic. And all stockpile must be removed by other parties. And hydroseeding probably should be done after the gravel removal just because then we can hydroseed that area as well.